Yo, good morning, good evening, good afternoon, good whatever time of day it is and whatever part of the world you're at right now. Welcome back to my channel. I'm doing a special video today for a class in Broward County, a middle school class in Broward County. Miss Naomi St. Gerard's class, a couple of her students gave me a couple shout outs. They even subscribed to my channel. They asked me to do a little video on multi-step inequalities and solving those word problems. So we just gonna go ahead and jump right in and get to it.
So let's talk about this. Translating basically means taking what's in English and writing it into mathematics, okay? And then we're also going to solve that. So for this first one, it says 7 more than. When you read that first part, 7 more than, that's going to be translated as plus 7. That's the first thing. Now, the next part says 3 times a number. So 3 times a number is 3 times a variable. Usually, most of the time we use X. But if you want to use the letter of your first initial or your last initial as your variable, you can. So for me, I'm going to use K because my last name starts with the K. So I'm going to put 3K, which is the same thing as 3 times K. Now, the next thing we want to take a look at is the part that says is greater than. That's going to be our inequality symbol.
Always look for is. Is either going to represent an equal sign or it's the beginning of an inequality sign, okay? So if it says is greater than wants to eat all of that. So this would be greater than.
And then that last part is 34. So here we go. Now that we've converted that from English to mathematics, now we're going to take time to solve it a little bit.
3K plus 7 greater than 34. I like to draw a line down the middle like that. Then we're going to start by subtracting 7 from both sides. So minus 7, minus 7. What you do to one side, you do to the other. That's going to become 3K greater than 27. And then our last step is to divide both sides by positive 3. Now I'm emphasizing the positive 3 because if we had divided by a negative, we would have to have changed the inequality symbol. So since we divided by a positive number, our inequality symbol is still going to stay greater than, and then we just evaluate 27 divided by 3, which is 9. So our value can be any number bigger than 9. All right.
Now let's take a look at this next one. 15 less than twice a number
is less than or equal to negative 23.
Now, the less than, because a lot of people make a mistake with reading 15 less than. When you read that, that's not 15 minus, that means negative 15. So I'm going to write it that way, negative 15. All right. Next, the next part is twice a number. So twice a number is 2 times some letter. So once again, you pick the variable that you want to use. This time I'll pick X, so I'll put 2X, which represents 2 times X. Now, here's our inequality symbol. Remember, I told you the word is kind of lets you know that's where you should be looking for your symbol, your equal symbol or your inequality symbol. Now, is less than
equal to. Less than looks like a crooked L because if you take a look at the word less, the symbol is kind of like an L, but it's crooked, it's a little slanted. So that's another way to remember less than. But since this is less than or equal to, we have to put the line underneath it, like that, okay? So.
And it says less than or equal to negative 23. So we're going to put that, negative 23. And now we're going to take time to solve this inequality. So I would write
2x minus 15 less than or equal to negative 23. And then we're going to go from there. I'm going to draw my line. That lets me know that there's 2 sides. And then we're going to start by adding 15 to both sides. You always want to do the additive inverse. So the additive inverse to negative 15 is positive 15. And we do that on both sides. This would make 2x less than or equal to negative 8. And once again, we're going to be dividing by a positive number. And since we're dividing by a positive number, the inequality symbol does not change. It does not reverse. So this would be x is less than or equal to, and then we go ahead and evaluate negative divided by positive is a negative, and 8 divided by 2 is 4. So our answer for this one can be -4 or anything less than -4, okay?
I'm going to ask you to take a look at some of these word problems.
Number 8 reads, the school will not announce O Day unless there is at least 10 inches of snow on the ground. If it has already snowed 1.5 inches or 1.5 inches, how much more must it snow before school is canceled? All right, so
let's see here. We need to define our variable first. That's what you should always do first. So what is our x going to be? And I'm going to just say we're going to use x to represent our variable for these. So let x equal what? What has to change, or what do we want to see grow, increase, or decrease? And for this problem, how much snow how much must it snow before school is canceled? So we're gonna let x equal the amount of snow, because that's what we're looking to change, increase, or decrease. So amount of snow. Let me zoom in here. There we go. So we have our amount of snow, that's our variable. Now, one of the first things we read was this phrase here. It says, is at least 10 inches. Okay, so of snow. Let's complete that. Now, is at least 10, is at least translates to greater than or equal to. Okay, so let me take a quick
side break over here, and I want to put this here. Is at least. This is another way of saying greater than or equal to, which means that you'll have this symbol. Now, another phrase we see sometimes is at most. Is at most means less than or equal to. So that would look like this. Now, another way to think of is at least. At least means it's saying that that's the smallest number that it can be, but it can be anything bigger than that. So another way of thinking about is at least is thinking that the smallest a value can be, which also means that we can have a value larger than. Alright, and I'm going to just leave it at larger than. Now, so once again, is at least is another way of thinking that the smallest a value can be, which also means that we can have a larger value than that one. Okay? Now, is at most obviously means the opposite. It's the largest something it can be, which also means that you can have values smaller. Okay? So let me write that down. The largest a value can be, which also means that we can have values less than. Okay? So I just want to go over that because these are two things that everybody, children and adults, get confused and make mistakes on. Is at least and is at most. Okay? So let's go back to our problem now.
All right, so going back to this. If it says is at least 10, that means that our inequality symbol is greater than or equal to, and we want 10. All right? Now, also, it says it has already snowed 1.5 inches, and says how much more snow must fall. So it has already snowed 1.5, which means the ground, right, already has it, or that area already has the snow. So that's a positive 1.5. And now the next part, it says how much more snow. So we said X is the amount of snow that it must be, the X is the amount of snow. So if it says how much more we're going to be adding, how much more will we add to that to make it 10 inches or more than 10 inches? And now we can go ahead and solve this inequality.
Okay. So to solve it, we would just start off by subtracting 1.5 from both sides. And when we do that, that becomes x is greater than or equal to 10 minus 1.5 is 8.5. So this tells us that at least 8.5 more inches. Okay, that's how we translate that. All right, let's take a look at
number 11. Let's skip around here because my homies, the little homies, said they definitely wanted to do some two-step word problems. So
we'll take a look at number 11 and go from there. Number 11 is another one-step word problem, but we still want to take a look at it though. Okay, and then we'll take a look at numbers 12 and 13. Okay, so let's go ahead and jump in and take a look at number 11. And once again, the steps
that we want to take when we're doing this, we want to define the variable, we want to set up an inequality, and then we're going to solve it. Okay,
so here we go. It says Kevin is taking a 2-part test in social studies. Part 1 is multiple choice and worth 60 points. Part 2 is an essay portion and worth 40 points. He must earn at least, there's that phrase again, at least 86 points to pass the class. If the teacher has already graded part 1 and he has earned 54 points, so already graded and earned 54 points, which means he has that already. That's in the bank. How many points will he need to earn on part 2? Okay, so
let's see here. We got to define our variable, and it says how many points will he need on part 2. So we're going to say let x equal number of points on part 2.
Some people may say another way to represent x, we could say let x equal score on part 2. That's another way to say it, okay? So if you and a partner, one of you all wrote the number of points on part 2, somebody else said the score on part 2, y'all would be saying the same thing 2 different ways. It's like somebody saying this is lit, somebody else saying that was cool, all right? Y'all are both saying the same thing, just using 2 different ways of saying it.
Okay. But I'm going to erase this second one, and let's keep on going. So now that we know that x represents the number of points or his score on part 2, we want to go ahead and start breaking this down. Now, the first part that I highlighted was at least 86 points, which means greater than or equal to 86, okay? Already graded and earned, that means he has it already. That is plus 54. He has that already. And now we want to know how many more points will he need. So we're going to say that that's what x is. If he gets that many points additional, he'll have at least an 86 or more.
So now, if we're solving this, remember I like to draw my line down the middle. We're going to start by using our additive inverse, which is negative 54. So we're going to subtract 54 on both sides. And when we do that, x becomes greater than or equal to 32. So, who is this? Kevin needs at least 32 points or more. Okay. All right. Let's take a look at these last 2, and then we'll be done with our little lesson for today. Number 12. Number 12 reads, Caitlin works a part-time job at the bookstore, which pays $55 a week. She has already saved $120 towards the purchase of a new $450 iPad. How many weeks must she work in order to have more than the amount of money to buy the iPad? Now,
have more than the amount of money. So we have a few things here. We have a bookstore, job at the bookstore, pays $55 a week. Then she already saved $120, right, towards a purchase. And they also told us that the purchase is a new iPad for $450, and she wants to have more than the amount. of money to buy the new iPad. And then other than that, we need to define our variable. So that's a lot, but let's take our time and break it down. Now, if we start with the first part, $55 a week, that's our rate, okay? So, let's start off by defining the variable. Always define the variable first. So, let X equal. Now, X in this case is going to represent weeks she must work, okay? So, weeks, number of weeks worked. Now, let's go to this. We need to figure out how much she earns each week, or how much she makes each week, or how much she's paid each week. So the very first sentence says she's paid $55 a week. So when we translate that, that is like saying 55 times X, or 55X. It says she already has money saved, so that's plus 120. And she wants to have more than, not the she doesn't want to have exactly $450. She wants to have more than $450. So we're just going to use the greater than symbol. And then we're going to put 450. Okay?
So now we can go ahead and solve this two-step problem. And I'm probably going to need some extra room, so I'm going to write down that way a little bit. Now, once again, we start off with the additive inverse, which means that we're going to add negative 120 to both sides. Some people may say subtract 120 from both sides. That's the same thing. When we do that, we get rid of the 120s. So we're left with 55x. And if you want, you can cross out the 120s. 55x is greater than, and then that's going to be 0. 5 minus 2 is 3. 4 minus 3 is 1. 4 minus 1 is 3. So we have 55x greater than 330. Then we want to do the inverse of multiplication. Remember that this right here, 55x represents 55 times x. So if we do the inverse, or the opposite of multiplying, we would be dividing. So we're going to divide both sides by 55. And since we're dividing by a positive, the symbol stays the same, stays facing the same way. So we're going to have x is greater than, and when you work that out, that is going to become 6. Okay? So x is greater than 6, which means that what's her name? Caitlin. So we would say Caitlin needs to work more than 6 weeks. More than 6 weeks, okay? In order to have enough money to pay for that new iPad. All right, number 13, and this will be the last one for our lesson today, and we'll wrap up here, okay? Number 13, the parking meter charges $2 for the first hour, then 75 cents for each hour thereafter. Nate only has $5. How many hours can he park? How many hours can he park?
So, first things first, we have to define our variable. We let x equal something. Now, usually the question, this is the question here, because it has a question mark. Usually the question is where we look for what we're going to use to represent our variable. In this case, it says how many hours. So we're going to say let x represent the number of hours after the first hour, because for the first hour, the rate is the same. It's just $2. And then it says it's 75 cents for each hour after that. So we're going to say the number of hours after, right? The first. After the first hour. We have to be specific there. I know that's a lot, but it's not just the number of hours, the number of hours after the first hour. Okay? So now that we've set that up, let's go ahead and break this down. Let's look for our rate of change. Our rate of change is 75 cents for each hour thereafter. So we would write that as 0.75 times x, or 0.75x, because it costs 75 cents for each hour after the first. Now, For the first hour, though, it charges $2. So no matter what, you have to pay $2. If you want to park for 30 minutes, if you want to park for 10 minutes, you have to pay $2 in that first hour. Okay. And after you go over an hour, then that's when they charge you 75 cents for every hour after that. But since no matter what, you have to pay, wrong marker. Since we have to pay $2, you have to come up off that $2 regardless for that first hour. Now, Nate only has $5. So if he only has $5, can he go over $5? No, because he doesn't have more than it. So he wants to spend as much of that $5 as possible, if not all of it. So if he only has $5, that means that he can't go over it. So it has to be less than, right, 5. Now, if potentially, could he spend exactly $5? Maybe. But we know it can't be more than. So it has to be less than or equal to 5. All right?
Now that we've set that up, we can go ahead and solve our inequality. Okay, first, once again, we start with the additive inverse. Since it says plus 2, we start off by subtracting 2 or adding negative 2 to both sides. Now, when we do that, that's gonna, the 2's cancel out, and then we have 0.75x is greater than or equal to, less than or equal to 3. Now, for these type of problems, these are really non-calculator problems. So what I'm going to show you to do is to work this out by hand without using a calculator. In order to do that, I want to change 0.75 to a fraction. And that's a commonly used fraction. So I already know that 0.75 represents 3/4. So I'm going to rewrite this to say 3/4 x less than or equal to 3. Now, when you have a fraction and you're trying to solve the problem, we could do this in 2 steps. For example, I could multiply by 4 on both sides, then divide by 3. But to do it all in one step, what I want to do is multiply both sides by the reciprocal. So the reciprocal means flip the fraction. So I'm going to multiply both sides by 4/3. 4/3. Okay? Now, what that does, on the left side, the 4's cancel out and the 3's cancel out. And another way of thinking about this, 4 times 3 is 12, 3 times 4 is 12, and 12 divided by 12 is 1. So that's why we do that, okay? That's why we multiply both sides by the reciprocal of the fraction, because it's going to make the value, the coefficient of x, a positive 1, okay? So let me erase this off the side here. Oops. And now, let me try that one more time. There we go. Now, so once again, you multiply both sides by the reciprocal. We're going to be left with x. We didn't multiply or divide by negative, so our inequality symbol says it's less than or equal to. Now, for this part here, all right, I'm going to do that off to the side. Let's get rid of that last highlight part. So this whole part over here, I'm going to show you what that looks like just in case you don't know. You can rewrite the positive 3 as 3/1 times 4/3. That's how it would look. And when you multiply fractions, as you already know, you multiply top times top, bottom times bottom. 3 times 4 is 12, 1 times 3 is 3. And then you evaluate that. 12 can be divided by 3, which equals 4. So we would simply write x is less than or equal to 4. Okay? So getting back to our question, how many number of hours can Mark park? It says how many number of hours can he park? Well, the number of hours, remember x represents the number of hours after the first hour. So if he's already stayed an hour and x represents the number of hours after the first hour, that's really 1 plus 4, which equals 5. So to answer the question, what's his name? Nate can park for a maximum, right, of 5 hours. Final answer. All right, gang.
Once again, we live from Nolanville. Thank you all for the shout outs, especially from Miss Naomi St. Gerard's class out of Broward County. I appreciate y'all. Love y'all. And until the next time, we'll see y'all later. Deuces.